Hello everyone, I am Dr. Sonali. Welcome to CSC Core Concepts in the series of Compiler Design. So in my previous video, we have discussed about the finite state machines and in particular about the DFA, that is a deterministic finite automata. So we will be discussing some of the solved examples in this video. So let us see how to construct a DFA. And if you are not aware about what is the DFA and what is the purpose of it, I recommend you to please go through the earlier video before you start solving the exercise. So let us construct a DFA that accepts all strings ending with 0. So the requirement is that the all strings should end with 0. Now, so what will be my language set? The language set should be, I told you, that always start with the minimum one. So minimum I will have 1 0, 2 zeros and 1 0. See, that should end with 0, right? That is okay. But before this 0, there can be any number of ones and zeros, right? So before this 0, there can be any number of ones and zeros. So this is how my language set will look like. Now let us start constructing the DFA. So first of all, we have a state. We will have an initial state. That's fine. But it says that when I read 0, it will send me to an accept state. And if I am reading 1, it will move back to the start because I can have 1 0, right? So let us have start with the initial state. So Q0 is my initial state and this arrow indicates the start of the initial state. Now, if I input 1 0 value, then I will accept it because 0 is accepted. So I will reach a final state which is represented by double circle. Now, what if I have 1 here instead of 0? Then I will remain in this state. I will not reach to the final or the goal state, right? Now, after this 1 0 or 0 whatever, what about zeros and ones after this Q1? Right. So if I have 0, it is saying that I will remain, it is accepted. See, here we have seen 0, 0 is accepted. So this is the first 0, this is the second 0. It is accepted. Let's say my string is 0, 1, 0. So when I encounter the first 0, I go to this state. Then I am encountering 1, I will remain in Q0 state. And then again I have a 0, I go to the accept state. But what if I have 1? 1 at the end is something not acceptable here. So if I get again a 1 here, I will go back to the previous state, right? So this is how you can construct a DFA. So let us see the other example. So construct a DFA that accepts string over with 0 over 0, 1. So means that I should have all strings starting with 0. So my string should start with 0, nothing apart from that, right? But it can end with any number of zeros or any number of ones. So what is my language set? Start with the minimum 0, 0, 0, 0, 1. So starting with 0, but thereafter it can have any zeros and ones. Then starting with 0, thereafter it can have any zeros and ones and so on. So how will you construct your DFA? You start with the initial state and draw the minimum requirement, that is 0. You go to an accept state. Now what if here you have 1? Okay, so after the accept state, we said it should start with 0. And after that starting 0, you can have any number of zeros and ones which is accepted. So you will remain in the accept state even after you get any number of zeros or ones. But if you get a starting 1 which is not at all acceptable, right? So you go to another state that is called as a Q state. So this Q state is called as a dead state. It is called as a dead state because this is something which is not at all acceptable. A starting 1 is not at all acceptable. Dead state is also called as a trap, right? So means you are trapped here and you cannot move to any other state. Now suppose your string is starting with 1 and thereafter you put any number of zeros and ones. It does not make any sense because the basic requirement is at all not fulfilled, right? So after this one, whatever zeros and ones you have, okay, you will remain in the dead state only. You will not change the state. So this is how you represent a dead state or called as a trap. Now see, this is the beauty of DFA, that you have to show, although this 1 is an invalid input here, then also you have to show that even if I give any invalid input, where will I lead to? I will lead to a trap, that you have to show. This is what it makes it a deterministic finite automata. Now let us construct a DFA that accepts all strings over 0, 1. Okay, all strings over 0 and 1 of length 2. The string should be of length 2. It should not be more than length 2. So obviously let us first start. Now any string, the string can be anything. The machine will start at Q0. Now I can input it. So what will be my language set? Let us see my language set. Okay. So language set will be what? Strings can start with 0 or 1, but it should be of length 2 only. So 0, 0, 0, 1, 1, 0, 1, 1. Okay, so these are the 4 possibilities. So either you put a 0 or a 1, you will go to the next state, right? Thereafter, again, if you put a 0 or a 1, you will go to the next state, that is the final state. So here, if I am giving the string 1, 0, so here it is 1, accepted, go to the next state. Here it is 0, accepted, go to the final state. But apart from this, okay, I told you that the length should be at the max 2, not more than that, right? So after this, if I am putting 101 or 100, whatever I put last, okay, this is invalid. So even if I put 1 or 0, I will go to a dead state. Okay, so no string should be more than 0, 2, sorry. So if I have 1, 0, and then I am writing 1, 0, 0, whatever. So this all will lead to a trap. So in the trap state also, whatever you put after length 2, 0 or 1, you will remain in the dead state only. Next, so construct a DFA that accepts the string 0, 1 or a string of 1 followed by a 0. So it can accept two type of strings. The first string is that it should accept a string called 0, 1. Either it will accept a string 0, 1 or it will accept a string which has at least 1, 1 followed by 0. The follow should be only 1, 0, but there can be any number of ones, but at least 1, 1 should be there. So what is the language set? 0, 1 is okay. After that, you can have 1, 1 followed by a 0. You can have 2 ones followed by a 0. You can have any number of ones followed by a 0. So let us get started. So first let us make for this one, right? Simple one. So when you put 0, you go to the next state. Then you put 1, you reach the final state. So the string 0, 1 is accepted, right? Now, after this 0, 1, if you put anything, okay, after this 0, 1, if you put anything, you will go to a dead state, right? It does not matter whatever you put. Then let us come to the next possibility. If you put 1, you go to the next state, fine. Thereafter you put 0, you go to an accept state, fine. Now 1, 0 is okay. 1, 1, 0 will also be okay. So if you have 1 here in this state, you will remain in this loop only. So suppose my string is 1, 1, 1, 0. So 1, you go to the next state. Now if you have another 1, you remain in this state. Another 1, you remain in this state until you encounter a 0. So as soon as you encounter a 0, you go to the final state. But after this, okay, after this last 0, you cannot accept anything else other than zeros or ones, right? So if you have anything else apart from that, you go to the dead state. Thereafter, okay, one thing you can do here is that if you get 1 here, you can go back to this state again, okay? But if you get a 0, if you get a 1, if you get a 0, you will go back to the previous state. But if you get a 1, you will go to the dead state because the string cannot end with 1. Okay, so similarly here also, in this case, 0, 1 is accepted, fine. But what if this input is 0? You go to a dead state. Now, construct a DFA that accepts all strings that are over AB starting with A. So the string should start with A and it can be of any length, right? But only it should start with A. AB, AAB, ABB means after this first A, you can have any number of A's and any number of B's, right? So let us get started with the minimum string. If I have only one A, I will reach the final state. After this first A, I can have any number of A's and B's. It is accepted. But if my string is starting with B, I will go to a dead state or a trap state. So once I am in the dead or the trap state, I can have any number of A's and B's. I will remain in the trap state or dead state only. So these are some examples we solved, and my next video also we will be solving some more examples about the DFA. So please don't forget to like, share and subscribe to CSE Core Concepts and keep on solving and make yourself very powerful for solving any DFA problems. Thank you.